Ever wondered how large-scale systems like your favorite social media platform manage data so efficiently? The secret lies in a concept called consistent hashing. It's a bit like a genius librarian who knows exactly where to find every book in a library that spans the globe. But instead of books, we're talking about data. Millions, billions, even trillions of pieces of data, all neatly organized and easily retrievable. That's what consistent hashing does. It's a game changer for managing data in large-scale systems, making sure everything runs smoothly and efficiently. So, if you've ever been curious about the behind-the-scenes magic that makes your online world tick, you're in the right place. We're going to unravel the mystery of consistent hashing, break it down into bite-sized pieces, and show you why it's such a big deal in the digital world. So, buckle up as we dive into the fascinating world of consistent hashing. Imagine you have a cake to evenly distribute among your friends. You wouldn't want anyone feeling left out, right? That's exactly what consistent hashing helps us achieve in the digital world. So, what is consistent hashing? Picture it as a magic trick that makes sure each of your friends gets an equal slice of the digital cake. But instead of cake, we're dealing with data and tasks. And instead of friends, we have servers in a distributed system. In the simplest terms, consistent hashing is a way to distribute data across multiple nodes in such a way that the reorganization of data is minimized when a node is added or removed. This is especially useful in distributed systems where the addition or removal of a node can be quite frequent. Picture this. You have 10 slices of cake, but suddenly 2 more friends show up. With traditional hashing, you'd have to re-slice the whole cake to accommodate the newcomers. But with consistent hashing, you just cut 2 more pieces, leaving the original slices untouched. Consistent hashing creates a hash ring, and each node in the system is assigned a place on that ring. When a new node is added, it simply finds its place on the ring without disturbing the other nodes. Similarly, when a node is removed, its data is evenly distributed to the remaining nodes without causing a major reshuffling. The benefits of this approach are clear. Less data movement means less processing time, less network traffic, and thus a more efficient system. And just like with the cake, it ensures a fair distribution of data, preventing any one node from becoming overloaded. But it's not just about fairness. Consistent hashing also provides scalability, allowing systems to grow or shrink without major disruptions. This is crucial in today's world where data is growing exponentially, and systems need to be highly flexible. So, to sum up, consistent hashing is like a master pastry chef, ensuring every friend gets a fair slice of the cake, while also making it easy to accommodate more friends or say goodbye to a few, without causing a cake-cutting chaos. Just like our cake, data gets evenly distributed, ensuring everyone gets a fair share. That's the beauty of consistent hashing. Now that we understand the basics, it's time to delve a bit deeper into how consistent hashing works under the hood. Let's start with hash functions. Picture a post office sorting mail into different postal codes. Hash functions work similarly. They take in data and produce a hash code, kind of like a postal code for your data. It's a way to assign a unique identifier to each piece of data, and it's crucial in consistent hashing. Next, let's talk about the ring topology. Imagine a circular track with hash codes arranged around it like milestones. This is what we call the hash ring. Each point on the ring corresponds to a hash value, and each server in our system is assigned a point on this ring. When a new piece of data comes in, we use the hash function to get its hash code. We then place it on the ring at the corresponding point. But here's the kicker. The data doesn't necessarily go to the server at that point. It goes to the first server we encounter as we travel clockwise around the ring. This is what makes consistent hashing so special. But why is this useful? Well, when we add or remove servers, the only data that gets moved is the one between the added or removed server and its next server along the ring. This is a much more efficient process than traditional hashing methods, where adding or removing servers would require rehashing all the data. Let's consider a scenario. Suppose we have a system with 3 servers, and we want to add a 4th. In traditional hashing, we'd have to reassign roughly a quarter of the data to the new server. But with consistent hashing, we only move the data between the new server and the next one on the ring. The rest of the data stays put, which saves a lot of time and computational power. So consistent hashing is like a master juggler. It keeps all the balls in the air, ensuring that each piece of data gets its turn to shine, while also making it easy to add or remove balls from the act. With consistent hashing, we've got a system that's efficient, flexible, and ready to handle data distribution like a champ. Consistent hashing isn't just a concept, it's a real-world solution to some of the most challenging problems in data management. Let's dive into how it plays a pivotal role in distributed systems, databases, and caching. Imagine your favorite streaming platform. With millions of users worldwide, it needs a way to distribute data evenly across multiple servers. Enter consistent hashing, ensuring that the load is balanced and your binge-watching experience remains uninterrupted. Or consider popular social media apps. They handle billions of posts and interactions every day. Consistent hashing helps distribute this data across various servers, keeping your feed fresh and fast. Even databases employ consistent hashing. It helps in effectively distributing entries across multiple nodes, ensuring speedy queries and efficient data retrieval. So, whether you're streaming, posting, or retrieving data, consistent hashing is the unsung hero, silently ensuring a seamless user experience. From your favorite streaming service to the social media app you can't live without, consistent hashing is hard at work behind the scenes. Like any complex concept, consistent hashing has its share of misunderstandings. Let's clear up a few. One common misconception is that consistent hashing is only beneficial for large-scale systems. While it does shine in such settings, it's not exclusive to them. Even smaller systems can reap the benefits of a well-distributed workload. Another misunderstanding is that consistent hashing completely eliminates hotspots. It does help to reduce them significantly, but it's not a magic bullet. Some unevenness can still occur, especially when dealing with non-uniform data. Finally, some believe that consistent hashing is a one-size-fits-all solution. But remember, different systems have different requirements. While it's a powerful tool, it may not always be the best fit. Understanding these misconceptions can help us better apply consistent hashing where it's most effective, and not expect it to solve problems it wasn't designed to fix. With these misconceptions out of the way, we can appreciate consistent hashing for the brilliant solution it is.